Hi, and welcome. This is lesson 3.3 on factoring trinomials when the leading coefficient is 1. So the general form of quadratics is ax squared plus bx plus c. And these are called quadratic polynomials. This is a quadratic trinomial because it has the three terms. And so when you see that it has three terms and your first term is squared, that is what we're talking about with this lesson. And when a equals 1, then it just looks like x squared plus bx plus c. Because remember that if there's no number in front of the variable, we can always understand that there is a 1 there. And so when a equals 1, you get x squared plus bx plus c. So we're going to talk about how do we factor those. So First off, where it says how to factor on your notebook, please number from 1 through 5. Leave some space in between them so that you can write. Your first thing you need to do is check for a greatest common factor. You want to see whether or not you can factor out any common factor and the greatest common factor. And we've talked about that in prior lessons. Please refer to that if you don't understand how to factor greatest common factor. Step 2, make sure it's in standard form. X squared plus bx plus c. If you have bx plus something x plus x squared plus c, you're going to want to make sure you put it in descending order. This is degree 2, degree 1, and degree 0. So make sure that you have your constant term at the end and your squared term at the beginning. All right. 3, you're going to look for two numbers. We're going to call them P and Q, but they're just going to be two numbers such that P times Q, the product of the two numbers, is C, and P plus Q is B. And so you're looking for two numbers that multiply to give you the last term, C, and that when you add them together, you get that middle term, B. And once we've got those, you're going to rewrite the equation as x squared plus px plus qx plus c, because you remember that p plus q equals b, so px plus qx equals bx. So you're going to rewrite your middle term bx. Let's use a little highlighter. Your middle term bx is going to be equal to px plus qx. Okay? And then finally, you're going to either factor by grouping, because we now have four terms, so just like we practiced when we were doing factoring by grouping, or you're going to use the box method. You have four terms that you can put in the box in a 2x2 box. And we'll do at least one or two of both of those in the the examples that follow. The final factored form will be x plus p times x plus q. All right. A trinomial is prime and cannot be factored if, wait for it, if no such numbers p and q exist. What does that mean? In other words, you go through all of the factor pairs of C and none of them add to B. If that happens, you've gone through all of the factored pairs, so this is where you really want to list them out, and none of them add to B. That means you can't factor it, and you would write that this trinomial is prime. All right, let's see some examples. Factor each trinomial. So let's look at number 1, x squared plus 9x plus 20. First of all, I want to note that x squared and 9x both have an x, but 20 does not have an x. And 9 has as factors 3 and 3, and 20 has 2, 2, and 5. They don't share any common factors. There's no greatest common factor, but we have checked. And so our first step, check for GCF, we have done that. So now make sure it's in standard form. X squared plus 9x plus 20, we have. And we're good. So number 3, find two numbers p and q such that p times q equals C, and P plus Q equals B. So we're gonna do this. We're gonna write 20, and I'm gonna just put a little times sign here. So we're looking for numbers that multiply to 20, and then I put plus, and then 9. So they're add to 9, and then I'm gonna say we'll start with 1 times 20. It would be 20, but 1 plus 20 would be 21. And so I'm going to put an X to say that's not it. And 2 times 10 is 20. 2 plus 10 is 12. Not it. So we go to 3 won't go into 20, but 4 will. And so I say 4 times 5 would be 20, and 4 plus 5 is 9. So that's the pair we're looking for. Those are our numbers P and Q. And so we're going to rewrite this as x squared plus 4x plus 5x plus 20. And we use the numbers 4 and 5, P and Q. 4x plus 5x equals 9x. So there's no change in what I have written up in the example and how I've rewritten it. It's the same example, but now I can factor it by grouping. Let's do that one first. X squared plus 4x parentheses plus 5x plus 20, close that in parentheses. And then I say, well, what is the greatest common factor of x squared plus 4x? And that would be x times x plus 4. And then over 5x plus 20, what's the greatest common factor? Would be 5. And so I would put plus 5 times x plus 4. And here I see that they share that x plus 4 as their common factor. So I'm going to factor that out and write x plus 4. That's our common binomial factor. And when I take x plus 4 out of this first group, I'm left with x. And when I take it out of this second group, I'm left with 5. So put plus 5. And x plus 4 times x plus 5 is our answer for number 1. That's what that looks like. And you can always multiply it back out to see if you get the original. And you would. Okay, example 2. Our first step, check for greatest common factor. And I notice that 7, 49, and 56 all are multiples of 7. And so I'm going to take out a 7. So I get 7 times a squared plus 7a, because 7 times 7 is 49, plus 8. And 7 times 8 is 56. So then we are left with this part here that I've underlined. That's much easier to factor than having to deal with 7a squared plus 49a plus 56. And it's now in standard form, a squared plus 7a plus 8. And so now we can look for two numbers that multiply to c and add to b, which is 7. If you get confused, remember that the general form of quadratics, and we were using x as an example, but this one has the variable a, but it's the same idea. A x squared plus bx plus c. And if it's in standard form, the first coefficient is a, which in this case is 1. Inside the parentheses is 1. And b and c. It's just in alphabetical order, a, b, c. But you have to make sure that it's in decreasing order by the exponents, 2. And when x, it has a 1. And then this one has no variable, so it's 0. And then I just start with 1 times 8. 1 times 8 is 8. 1 plus 8 is 9. So that's not it. So I go to 2. 2 times 8. 2 times 4 is 8. And 2 plus 4 is 6. So that is not it. And Then I'll look at 3 won't go into 8, but 4 will, and I already got 4 times 2 times 4, so 4 times 2 is the same pair. So what that means is that what's left inside the parentheses is prime. The whole thing could be factored. We factored out 7 times a squared plus 7a plus 8. But that's as far as we can take it. We can't factor this any further. And so this is our final answer. 7 times a squared plus 7a plus 8. All right. Let's take a look at example 3. Example 3, we've got m squared plus 6m minus 16. They don't all have an m. They're all not multiples of 2 or 6, so there's no greatest common factor, but we've checked that. Now we want to make sure it's in standard form. It's decreasing order 2, 1, and 0 for the constant. So it's in standard form. So then we're looking for the numbers that multiply to C, which is negative 16, and that add to our B term, which is 6. And so I'm saying, okay, this time it's negative. So when I multiply two numbers to get a negative, that means one has to be positive, the other has to be negative. So if I just started with 1 times 16, that gives me 16, but it wouldn't give me negative 16. And so I have to decide, do I put the negative on the 16 or on the 1? And if I put it on the 16, let me erase that. If I put it on the 16 and the positive then on the 1, which you don't normally need to write, but we'll write it. Then when I add those together, I would get negative 15. I get a negative number, but I notice that 6 is positive. And so I'm going to switch it and put the negative on the 1. And then when I add them, I get positive 15. Now, that's not the numbers we're looking for. We're looking for 6. But we at least have the sign on the right sign, the larger absolute value. So I'm going to go to negative 2 times 8. Negative 2 times 8 is negative 16. And negative 2 plus 8 is 6. And that's what we're looking for. So when we're rewriting this, we're going to write m squared plus 6m minus 16. And I'm going to take these two numbers that I've found and rewrite 6m using those. So I'm going to write m squared minus 2m plus 8m minus 16. Those two, 8m minus 2m is 6m. Those are equal. So now, but I've written this now in 4 terms. Now I can write this. I'm going to use a box this time. And so I write m squared in the first box, and I write minus 16 in the last box. And it doesn't really matter how I put these other two terms. I'll go ahead and put minus 2m up here and 8m down here. So m squared minus 2m have in common m. And 8m minus 16 have in common 8. And m squared and 8m have in common also m. And negative 2m and negative 16 have in common negative 2. And before I write those, I just want to check that m times m is m squared, m times negative 2 is negative 2m, m times 8 is 8m, and 8 times negative 2 is negative 16. So those work, those factors. So I can then write my final answer as m minus 2 or m plus 8. And that is the factored form of that example number 3. Let's go to 4. For number 4, again, first I want to check for common factor, greatest common factor, and I notice right off the bat that each of those 3 terms are multiples of 5, and also that they have a p. And so I'm going to take out 5p, and that leaves me with p squared times the first, 5p times p squared is 5p cubed, minus 10p 5p times a negative 10p would be negative 50p squared. And then minus 5 goes into 120, 24 times. And so I get p squared minus 10p minus 24 is what's left on the inside. It's in standard form. We've taken out the greatest common factor. Now we can look at that separately and factor what's left inside here. And so I say we're going to multiply to c. Remember, c is our constant, and it's negative 24. So once again, we're having negative number, so that's going to be a positive and a negative factors that we're looking for. And they're going to add to our b term, which is negative 10. Really pay close attention to the signs. That's going to make or break you if you don't pay attention to those signs. Now, this time, the sum is negative 10, and so I want the larger absolute value to be negative. So I'm going to put 1 times negative 24, and all of my negatives are going to be on the larger number. So 1 plus negative 24 is negative 23, and that's not it, but the sign is correct. So 2 times negative 12. 2 times 12 is 24. 2 times negative 12 is negative 24. And then 2 plus negative 12 would be negative 10. Found it. So you might keep going, but I live by the idea that once you find what you're looking for, you stop looking, right? So, which is, by the way, the reason that you always find something in the last place that you look. Of course, because once you find it, you stop looking. So 5p times, now here I'm going to rewrite this, p squared plus 2p minus 12p and then minus 24. And I just make note that this minus 10p is the same as what I have rewritten here using the factors that we found. 2p minus 12p is equal to minus 10p. And so then I can factor what's inside here by grouping. So I'm going to leave my 5p outside. I'm going to change this parenthesis here to a bracket. And then I'm going to say inside I've got p squared plus 2p. Close the open the parentheses, close those up. I'm going to put plus, and then I'm going to put in parentheses minus 12p minus 24. And I'm going to close that up. And make sure that you always put a plus sign in between the parentheses. That minus, on that minus 12p, you might be tempted to put on the outside of the parentheses, and you're probably going to make a mistake when you do that. So don't put the negative out there. Make sure you put a plus sign. We've added a plus sign in there, but the minus that was on the 12p is still on the 12p. Then we take 5p brackets. We take out a p that they have in common, p times p plus 2, plus, and let's go ahead and make it minus because both of these terms are negative. So I'm going to factor out minus 12 times p plus 2. And I notice that, let's use blue. I notice that I notice that they have this p plus 2 in common. And so I'm going to factor that out. P plus 2 times p from the first group minus 12 from the second group. And the brackets are no longer necessary because everything in the inside here has now been factored. P plus 2 times p minus 12. But I need to add on the 5p that was on the outside. So I get 5p times p plus 2 times p minus 12. And this is the final factored form of example 4. All right. We could have just as easily taken this step right here and used a box to factor that out and just put those 4 in there, and we would have gotten the same answer, p plus 2 and p minus 12. All right, let's look at example 5. We've got 3x squared plus 24x minus 36. And it looks to me like they have 3 in common. 24 and 36 are multiples of 3. So yes, we can take out a 3 times x squared plus, and what times 3 is 24? 8x. And then what times 3 is 36? So that'd be minus 12. So once again, we're going to factor the inside here. We're going to say we're going to multiply to our c value, our constant, which is negative 12. And we're going to add to our b value, which is 8, and it's positive. So this time I'm going to put the positive on the 12. So positive on 12, negative on the smaller absolute value. And negative 1 times 12 is negative 12. Negative 1 plus 12 is 11. Now that's not the numbers we're looking for, but negative 2 times 6 is negative 12. And negative 2 plus 6 is 4. So that's also not what we're looking for. Negative 3 times 4. Negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. And that's also not what we're looking for. And if I go to negative 4, I mean, then it just flips it on its head here. Negative 4 times positive 3 would be negative 12, but negative 4 plus 3 is negative 1, and now we're getting into negative numbers. So at this point, we could say this part right here is prime. And so we're not going to factor it any further. We just say this is the factored form, and we're done with example 5. Now we'll go to example 6. N squared minus 8n plus 15. No common factors. They don't all have n's, and 8 and 15 don't share any common factors. And even if they did, n squared doesn't have anything in front of it. So no greatest common factor. Then I look at 15. Remember, we're multiplying to 15, and we're going to add to negative 8. This is a little different scenario. 15 is positive, but b, our b value is negative 8. It's negative. And so the way to get a positive number like 15 is if both numbers are positive, or if both numbers are negative, because a negative times a negative is positive. And because b is negative, we know that both numbers have to be negative. So we're going to start with just negative 1 times negative 15, and that would give me positive 15. But when I add them, I would get negative 16. And again, that's not the numbers we're looking for. We're looking for negative 8. So 2 won't go into 15, but 3 will. So I get negative 3 times negative 5 would give me positive 15. Negative 3 plus negative 5 is negative 8. So those are the numbers that we're looking for. So I'm going to rewrite this as n squared minus 3n minus 5n plus 15. And again, make note that these two terms combine to give me minus 8n. So it's the same thing, just rewriting it now. This time I'm going to use a box. And so I'll put n squared here and plus 15 here, minus 3n here, and minus 5n here. And I say for this first column, n squared and minus 5n, they have an n in common. And for the second column, minus 3n and 15, they have 3 in common. And I'm going to come back and do the signs afterwards. N squared minus 3n, they have an n in common. And minus 5n and 15, they have a 5 in common. So now I need to think about where do I put the signs so that I can get those negatives that we have in minus 3n and minus 5n. And you'll recall at the beginning when we talked about your final factored form will be x plus p and x plus q. Once you've found the numbers p and q, that sort of is going to give us a hint here as to what our final form is going to look like. So if I put, you do want to avoid putting a negative on your first term inside of each of the parentheses. And so with that said, we're going to put a negative on the 3 and a negative on the 5. And then we're just going to go around and make sure that we have everything multiplies out as it should. N times n is n squared. N times -3, -3n. -5 times n is -5n. And -5 times -3 is a positive 15. So we can say then with certainty that our factors are n minus 3 times n minus 5. And that is our final final answer. Okay, go practice. Good luck. You can do it.